cubic inequalities, or el cubico inequalitares, as they say, probably not in Mexico. So to solve inequalities, we like to sketch graphs. We've done this a fair bit with quadratics. I think that's the best way to avoid any errors. As you get to know these equations better, you can do it without sketching the graph, but I still think it's a good habit to get into, just to avoid any silly mistakes that you could make. So if we were solving this cubic equation, x bracket x plus 3, bracket x minus 2, we know our x-intercepts are -3, 0, and 2, so we have the full sketch of the graph, and we're looking at where this graph is less than or equal to 0, that is, touching the x-axis or below. So you can see here we have the sketch of just those values, if we break it up into the parts there. So we have -infinity to -3, all those x values that fit that, or 0 to 2, and we have square brackets there because it is an equal to sign in the original equation. So just keep that in mind. We don't have to worry about turning points. It doesn't have to be a great sketch. We're really just looking at those x-intercepts in most cases. I hate sketching live, and it's all this lesson is. Anyway, so x-intercepts at -2, 4, and 6. So I'm going to go about there, a bit further along, a little bit further along there. Again, it doesn't have to be perfect, and we don't have any reflections. There's no negatives in front of the bracket, so it's a up, down, back up type thing. And that's it. Doesn't have to be great. That'll do us. And we are now looking at the values where this graph is equal to the x-axis or above. So that would be here and here. Sometimes I use a highlighter to represent that. So that would be when x is an element of -2 to 4 or 6 to infinity. So just getting your brackets right is really important. I'll just reiterate, if you ever write that, don't go over it with a square bracket. An assessor cannot tell which you're using there. So just skip that, erase it, whatever, and start over. Make sure you're really clear with your brackets. And of course, we always talk about our relevant domain from left to right, as we would with range, which is bottom up. And this graph is in point of inflection form. So you can see here we have a point of inflection at 2 and -64, so somewhere down here. Doesn't really help us too much, but does give us a kind of gauge of what the shape of this graph may look like. Let's look for some x-intercepts here. So if I make y 0, I end up getting 64 equals x minus 2 to the power 3. Cube root of 64 is 4, so that's x minus 2 there, and that's going to give us 6 as our x-intercept, so somewhere along here. Just a general sketch, best we can do. Don't really need to label this, but I'm going to anyway. And we're talking about just this section of the graph above the x-axis, so this equation being greater than 0. So that would be 6 to infinity. Oh, come on. And it's a curved bracket for 6, as we are not including that value as the question dictates. There's another tricky little one. So we've got a 3 here. If we did our discriminant for this, in fact, let's even just do it. So it's b squared minus 4 times 1 times 6, and that is 24. You can see that we're going to get -20, a discriminant of less than 0, meaning that we do not have any x-intercepts from this quadratic portion of the equation. So we just have our x-intercept at 3. This graph, so our y-intercept would be -18. So if I multiplied -3 and 6, I get -18. It'd kind of be something like that. It doesn't have a point of inflection, but it has this x-intercept at 3. At the end of the day, it doesn't really matter if our sketch is any good. We're just talking about where this graph is above the x-axis, and that is from 3 to infinity. So it doesn't matter with the quality of the sketch, getting that x-intercept's the most important part. For our last question here, we need to factorize first, so I've just used long division, but as always, synthetic division would be fine as well. And I've just added a little bit more working in orange on the right. So once we factorize, we get x minus 1, and then we can factorize our quadratic of x squared plus 2x minus 3 to be x minus 1 and x plus 3. That gives us x-intercepts at 1 and -3. Now, really importantly, this x minus 1 squared means that the function is just touching the x-axis at that value of 1. And we don't have any reflections here, so -3 and 1. So this will come up, come back down, just touch, and go off that way. Not great, but good enough. And we are talking about where this graph is less than or equal to 0. So that is all of this bit here, as well as our x-intercept at 1. So negative infinity, left myself much space there, and 3, and then including 1. So getting your notation right is really important, getting your brackets right, sketching, just taking your time with this stuff. Once you sketch, you can see it's pretty easy to read your values from there. And I just use x as an element of as a great way to state your relevant values for these graphs and equations.